Hi all. Today we are going to discuss about the important components of laser. What are the components which are required for producing a laser? First of all, how many components are required? First one is active medium. Three components are actually required. The first one is known as active medium, or another name is lasing medium. This is the medium where laser action takes place. Second one, we require a pumping source. Pumping source. Third one is optical resonator. Optical resonator, or another name is resonant cavity. These are the three important components which are required for producing laser action. This is an essay question, so you have to explain it in detail. So what is meant by an active medium? Active medium means where the laser action is taking place. So it can be a solid, liquid, or a gas medium. Here the light get amplified because laser expansion was light amplification by stimulated emission of radiation. So this is a medium where laser action takes place. That means light is getting amplified in this medium. It can be solid, liquid, or gas. Active medium is actually placed between two reflecting mirrors. In between two mirrors, we are going to place an active medium. Then the fraction of atoms which are responsible for this light amplification are known as active centers. That means all the atoms may not be actively participating in the reaction. So the number of atoms, or the fraction of atoms which are responsible for light amplification, are known as active centers. This much is enough for active medium. Then what is meant by pumping source, or what is the need of a pumping source? We have already discussed that three requirements or three requisites are there for a laser action to take place. One was population inversion condition. That means normally atoms were residing in the ground state. We have to pump all these atoms, or majority of the atoms, to the higher energy level so that we can start stimulated emission process, isn't it? So for that, what we have to supply? We have to supply some energy to this medium. Only then these atoms or electrons can absorb this energy and can go to the higher energy level. For that, we require pumping source. So it supply energy to the active medium. Pumping source supply energy. Pumping mechanism actually helps to obtain population inversion between a pair of energy levels of the atomic system. That is the significance, or that is the function of a pumping source. Then the third one is optical resonator, or it is also known as resonant cavity. It is the important one in this components, because actual action or working of laser is taking place in optical resonator or resonant cavity. So it consists of, what is its structure? Actually it consists of two mirrors. Two mirrors. Mirrors will be in this shape, that is concave mirrors. There will be two concave mirrors which are placed coaxially. One will be fully reflecting, 100% reflecting, and the other will be partially reflecting mirror. And in between these two mirrors, we are going to place this active medium. It can be a gas, liquid, or a solid material. Suppose if it is a ruby laser, ruby is a crystal, you are going to place that crystal here. Or suppose it is a helium neon laser, helium and neon are gas, we are going to place that mixture of gas inside these two mirrors, in between these two mirrors. So here is the active medium. Active medium consists of active centers, isn't it? So it consists of active centers which are responsible for laser action. And also here we are supplying some energy to this active medium, and it is pumping source. So this is the structure of an optical resonator. one mirror will be 100% reflecting and the other will be only partially reflecting. That means half of the light rays may be get reflected back to the same medium, some may be going through, refracted through the medium, okay, to the next medium. That is, this is the structure of an optical resonator. Then what are the functions of an optical resonator? That is very important. Mainly there are three functions or three significance. Three duties are there for an optical resonator. First one is known as positive feedbacking of photons. We will discuss it in later. Positive feedbacking of photons, because we require light energy. Laser is light energy, so it is positive feedbacking. Then the second function is filtering of unwanted photons. Unwanted photons, we have to filter it out, because you will get a collimated directional beam. In order to ensure that, we have to filter unwanted photons. And the third one is achieving optical gain by amplification. These are the three important functions of an optical resonator. So what is meant by positive feedbacking of photon? We know that if we are supplying energy by pumping source, this active medium consists of many number of atoms or electrons which may be in their ground level, but they will absorb this energy and get excited to the higher energy level. And as the higher energy level is highly unstable, they will come back to their metastable state and they will reside there for a long time, so that population inversion has been achieved. When this population inversion has been achieved, any photon, maybe by stimulated emission or by spontaneous emission, any photon can trigger a stimulated emission process of these atoms to the ground level, and it will give you two photons. These two photons will travel towards this mirror. Then as it is partially reflecting, some photons may get escaped. Then if suppose these two photons are getting back, we are supposing that if these two photons are getting reflected back to the same medium, it can trigger another two atoms. Then as a result, you will get 4 photons traveling in this direction. As it is 100% reflecting, all the photons will get back to the same medium again, and it will thus the photons will shuttle in between these two mirrors through this active medium, and they will activate more and more atoms to get back to the ground state, and we will get more number of photons. So this is actually positive feedbacking of photons. Some photons may get escaped through this partially reflecting mirror. Then filtering of unwanted photon is the second function or second duty of an optical resonator. Filtering means, as these atoms are in different having different energies, there is chance for the atoms to emit photons in different direction, but we require only photons which are traveling parallel to the axis of the mirrors. Only that photons will give you laser, because it will be collimated, it will be focused, and they will be traveling in the same direction. So unwanted photons should be eliminated. For that, these two regions are open. If the photons are traveling in this direction, they can get escaped from this active medium. It will not get multiplied, isn't it? Only photons which are going within these two mirrors will get amplified. So that is filtering of unwanted photon. The triggering photons may be emitted in random direction, which may produce stimulated emissions in different directions. It must be prevented. So for that, photons with random unwanted direction must be filtered out. Then the third function or third duty of an optical resonator is to achieve optical gain by amplification. That means optical gain should be greater than optical loss. Optical loss means, as it is a partially reflecting mirror, some of the photons may be get escaped through this mirror. So we have to obtain an optical gain, more number of photons which are reflected back to the same medium than the number of photons getting lost. Okay, that is actually optical gain. That is the threshold condition. Only when the number of photons which are reflected back to the medium is greater than the photons which are escaped, we will get a collimated intense beam of laser through this partially reflecting mirror. This is actually the working of a laser. It is general for all the lasers. All the lasers will have an active medium. All lasers will have a pumping source. Everyone will have an optical resonator. This is general for all the lasers. Then we will go into detail into specific cases like ruby laser, helium neon laser, etc. But this is a main very important question. What are the main components of a laser? These three are the main components and it can be asked as an essay question. Okay. Now we are moving on to our first laser, that is ruby laser. It is repeatedly asked essay question in our university examination. Ruby laser. It was discovered by T.H. Mayman and it is in 1960. Question will be like, outline the principle and working of a ruby laser. So it is the first laser and it is a solid state laser. Ruby means it is a crystal. So the active medium here is a solid material. Now, how will you explain its working and its principle? We have to explain about its three components. That's all. Three components means what is the active medium here? You have to explain it in detail. Then what is the pumping method used? You have to explain it here. That is specific case. What is the pumping method used in ruby laser? And how is the optical resonator working in ruby laser? That's all. That means this is the framework. Framework is this one. For every laser you have to explain it in detail. So what is the active medium here? Ruby laser, we have already stated that it is the ruby rod. Ruby rod means it is aluminum oxide Al2O3 crystal doped with 0.05% of chromium oxide Cr2O3 is known as a ruby rod, and that is our active medium. Okay, but here active centers will be only chromium ions. Only chromium ions, Cr3 plus ions are the active centers, while aluminum and oxygen are inert. So that's all about active medium. Then what is the pumping method used in a ruby laser? Pumping method used in ruby laser, we have discussed about 5 different pumping methods. Optical pumping, electrical pumping, electric discharge pumping, atom-atom inelastic collision, chemical pumping, etc. Which type of pumping is used in a ruby laser? That is optical pumping method. We are using an optical pumping method, specifically using a xenon flash tube. We are using a xenon flash tube and it will help you to obtain population inversion condition. So that's all about pumping method. Then what is its figure? How it look like? It consists of a ruby rod, that means aluminum oxide doped with 0.05% of chromium oxide, and it will be in the form of a rod. Here the rod itself, the two sides of the rod, we are polishing it so that the one side of this rod will act as a 100% reflecting mirror and the other side will act as a partially reflecting mirror. So the ruby rod itself acts as optical resonator here, and over this ruby rod we are wounding a xenon flash tube, helical shaped xenon flash tube. Here it is, there is an electrode. These two sides are acting as electrode. Okay, so inside this rod all these laser action will take place. Pumping method is xenon flash tube. When this flash tube is on, it will supply energy to the chromium ions, which are the active centers here. Actually the ruby rod will be pink in color. Pink. The first ruby laser, when it was made by T.H. Mayman, he had taken its length as 4 cm and its diameter was 0.5 cm. Its two end faces will act as mirrors and a helical shaped xenon lamp is used as pumping source. When this power supply is on, chromium ions inside this ruby rod will absorb not all the energy. It will absorb only green and blue components of the light, because its energy level is such that atoms from the ground state can get excited to this energy level only if it absorbing some green color, it can go to some kind of energy level, and if it is absorbing blue, it can go to the another excited energy level. So chromium ions will only absorb green and blue components and get excited to the upper energy level. But we know that all these upper energy levels, suppose it is E3, E2, this is ground state, all these upper energy levels are highly unstable. It will come back to the metastable state that we have already discussed. But this transaction or this motion will be non-radiative. During this transition, it is not radiating any type of energy. It may be through collision with other atoms or something like that. It will lose its energy and go back to the metastable state. And the atoms will wait there for a long time, so that number of atoms in this metastable state is larger than or greater than number of atoms in the ground state. Now here it is, a population inversion has been achieved. Now if we are again supplying energy, any of this photon can act as a stimulant, and this atom can emit another photon of this kind and come back to the ground state, isn't it? So this is the working. When population inversion is achieved, it can emit laser. Okay, laser not in a first step itself. Here, as these two mirrors are acting as two sides are acting as mirrors, photons may be traveling in this direction, getting reflected back, again act as stimulant, another photons will be created, 100% reflecting mirror, it will reflect it back to the same medium, that is some kind of positive feedbacking, and the number of photons will multiply. And when this optical gain is become greater than optical loss, number of photon lost, we will get collimated beam through this partially reflecting mirror. And very important value is what may be the wavelength of the ruby laser, that you have to keep it in mind. Wavelength of ruby laser will be 6943 Armstrong. The xenon flash tube, in the name itself it is only flash, that means its light will last only for few milliseconds. So you will get laser as not as a continuous wave, it will be like pulses. Output will be like, if you are drawing a graph between time and output, the graph will be like this pulses, and it is known as spike. It may not be in the form of a continuous wave. And this is ruby laser. But here energy level diagram is also very important. Figure this one you have to draw, and the energy level diagram you have to draw. It should be in a neat format. That means which are the upper energy level, which is the ground energy level, which is a metastable state. Clearly you have to draw it. So here ruby, as it is a ruby rod, it consists of two energy band which are acting as upper energy levels. These are two upper energy levels. There will be some ground state, and in between there is a metastable state. So if you are supplying energy by pumping, atoms will absorb energy. These atoms are excited to this upper energy level by absorbing green component of light. Some atoms are get excited to this energy level by absorbing blue component of energy. But as these two energy levels, take any names like E1, E2, E3, something like that, suppose it is E1 and E2, as these two are highly unstable state, they will come back to the metastable state, isn't it? But no, by non-radiative transition. And when this number of atoms become greater than number of atoms in the ground level, population inversion has been achieved. Now any stimulated or spontaneous photon can act as a trigger, so that this atom will get stimulated and it will emit a photon of the same kind, and then you will get two photons. But there is a mirror, it will reflect the photons to the other side, again it will trigger another two atoms, isn't it? And this, they come back to the ground state. But we are supplying energy not as continuously but as flashes, so there will be some time gap between this transition, so you will get the output in the form of spike. This is known as spike. Time on the x-axis, output power on the y-axis. So here, if you are having this ground level and one of this excited state and metastable state, you can attain a laser action, isn't it? If it is E1 is not there, E2 is there, then ground state, E2 and metastable state. That means at least here we require 3 energy levels. So Ruby laser is a 3-level energy system. And that's all for that essay. What are the merits of and demerits and what are the applications also, you have to read it. Merit means it is long life. As it is a ruby rod, it is long life. Ruby rod is pink in color, but the laser is red in color. And its wavelength is 6943 Armstrong. Output power of a few kilowatts can be obtained. That are the merits. Demerit means laser output is pulsating, not continuous. And it is low efficiency because we have to supply large amount of power so that we can attain population inversion condition. And the ruby rod will get heated up, so extra cooling is also required. That are some of the demerits of ruby laser. Application means common for all the lasers. Lasers can be used in pulse echo technique that we have studied in NTT, in ultrasonics, NDT. Pulse echo technique we can use laser. For holography, that we will discuss in the next section, we can use lasers. For laser drilling, laser cutting, trimming, etc., we can use it. Then in spectroscopy, in surgery, and in laser weapons also. So today we have discussed 2 important essays. First one is components of laser and second one is specifically ruby laser. Okay. And next video we will discuss helium neon laser and semiconductor diode laser and all the lasers applications. Thank you.